All right, so number one, measure of angle AOB. So what are we saying? The following figures, relationships. So we're looking at those angles, and those angles are given. Find the measure of the marked angles. Okay, so find the measure of the marked angles. Right down here, if you can see this little diagram, maybe I could make it a little bigger right here. Probably be a good idea. A little bigger here, and this one like this, and it's saying this is angle X here, and this is angle Y here, and it's saying AOB is a fancy way of saying X is 1/3 of Y. So angle X is 1/3 of angle Y. That's what those are saying over there, right? AOB and COD. So X is 1/3 of Y. So what could we do to find X and find Y? Remember this problem? This is one of our, part 1 is chapter 11, part 2 is chapter 12. This exam is chapters 11 and 12. So part 1 is chapter 11. So remember this is way back from 11-1. This is like our first week of class. What are we going to do to find X and Y? Yeah, good. How do we know an x plus y is 90? Yeah, and you're doing the 180. Very good. Yeah, right? You see what's being observed there? That's 180, isn't it? Because remember, one side of a straight line is 180, right? If you go from right to left, that's 100. It's like making a U-turn in your car, right? If you're traveling down the road this way, and you go, oh, I'm going the wrong way. My kids always kid me because I often go the wrong way and need to make U-turns. And then you flip it all around and you start going that way. That's a 180-degree turn, right? It's a 180-degree rotation there. And this one in the middle is using up 90. So that means the X and the Y together must be the other 90, right, to make 180. So we know that X plus Y is 90. And then we also know that X is 1/3 of Y because they told us that on the side. We need that or we couldn't really finish this problem. So what do we do with that X equals 1/3 Y? Remember your algebra days? You can just like plug it in right there for X. In the X spot, we can say, well, that's 1/3 Y. And so the equation goes from X plus Y is 90 to 1/3 Y. Plus y is 90. Why? Because X is 1/3 Y. That's what they're saying right here. X is equal to 1/3 Y. So wherever you see X, you can plug in 1/3 Y. It's the same as 1/3 Y. So then we have an equation now, because we had to get it to where it only had one letter, huh? We can't have X and Y. There's nothing we can do with that. So now we're down to just one letter, just Y. And then how do we solve for Y there? What do we do for Y? How do we solve that equation when you got a fraction? Remember how to handle fractions? Multiply through by the denominator, by that 3. You have to do the same with an equation. You got to do the same thing to both sides, right? Remember that idea? If two things are equal and you treat them the same, they'll be equal afterwards. And so we get rid of the fraction by multiplying through by 3. That's really a 3/1, and so it cancels out that other 3. Remember all that kind of stuff? So what do we get? I'm kind of running out of room. Bring it over here. So we've got Y. It's just 1Y, because the 3 is canceled, plus 3Y. And 3 times 90, what's that, 270? Does everybody see how I got to that equation? See how the 3's canceled right here. So that just left 1Y, and then in the middle, 3Y, right here, 3Y, and here, 3 times 90, 3 times 9 is 27, 270. So 1Y plus 3Y must be 270. And so then, what's that, 4Y? 4Y is 270. 1Y and 3Y makes 4Y. 4Y is 270. Last step. To get Y alone, divide by 4. So Y is, I don't know, what is that, 62.5 or I'm sort of half guessing. Anybody got that with their calculator? 270 divided by 4. Whoops. 67.5. Thank you. Yeah. 67.5. So that's y, 67.5. And now, how do we get x? So we got y. Is everybody good with that? How do we now get x? Yeah, the easiest way would be subtract from 90, huh? Good observation. Because remember, x and y together make 90? Because remember, we had the 180 thing here, and there's 90 in the middle, so x and y are left with 90. So yeah, so you could just subtract from 90, huh? So x must be whatever 90 minus 67.5 is. What is that? 22.5? So x must be 22.5, y must be 67.5. We found them. They want them up there. AOB is x, so this is x. This one's the 22.5. This one's x. And COD, that's the what I called y, 67.5. There we go. Part B is the same thing. AOB is 15 less than 3 times BOC. So they're talking x and y again. And they're saying, okay, what are they saying exactly? They're saying AOB. Which one's AOB? Is it x or y? See down here? I'm looking down here. They're saying measure, that M stands for measure. Remember this one? Measure of angle AOB. So which one's AOB, x or y? Yeah, can you see they're real tiny? This is x, this is y. Yeah, it's the y, huh? So they're saying y is, remember is equals, right? Y is, AOB is 15 less than, so that's going to be 15 subtracted at the back, less than what? 3 times BOC, 3 times x. So it's 3x minus 15. That's 15 less than 3 times BOC, 3 times x. Is that good there? So we've got that. And then what else do we know about? So we always need, when we have 2 letters, we always need 2 equations. Have you noticed that? With x and y, 2 letters, we need 2 equations. So we need another equation. What would the other equation be? You got me 90, yeah. Together they make a right angle, don't they? So yeah, good. So x plus y is 90, and now we just do the same thing. We just plug in. Y is 3x minus 15, they told us. So that means we can plug in for y 3x minus 15, because it is 3x minus 15, huh? It equals 3x minus 15. So I'll grab that and I'll pop it in. So what do we get then? We get x plus, and then it's going to be 3x minus 15 is 90. Just plugged in for y, 3x minus 15. And so now we have an equation with just x. We can solve it. Remember how to do this. So this one's nicer, huh? No fractions in this one. 1x and 3x. That just makes 4x. Remember equation solving? What do we do there to get x alone? Right, x is here. I'll bring it up here. X is saying, I want to be alone. That's what x is always saying in an equation. 4x minus 15 is 90. An equation is like a wall with left side and a right side. And the x is saying, I want to be alone. So what do we do to get x alone? Yeah, add that 15 over. Yeah, exactly. Where we do the opposite of whatever's with x, huh? To get that x alone. And so that cancels that out. And 4x is, what's that, 105. And then last step, divide by 4. And somebody had that one on their calculator? 26.25? Thank you. 26.25. So that's x. And then how do we get y? Subtract from 90 again, huh? Because they make 90 total. So that's 26.25. So then y, come over here. Y, I don't know if it doesn't really look like a y. Maybe I'm kind of running out of room everywhere. I'll put it up here now. So y is 90 minus x. Y is 90 minus that 26.25. If you can read that, let's get kind of scribbly. Equals equals 90 minus 26, 25. And what is that? Oh, yeah, thank you. 63.75. So there's angle Y. There's angle X. We got it. All right, so there's part C. Part C, I'll make it bigger here. There we go. I made it bigger. They want us to, I don't know what, let me go back to the information. What are they telling us? Explain why exact values of X and Y cannot be determined. So as you look there, why can't we find out exactly what X and Y are? Well, yeah, we just don't have enough information, huh? We know that 3 X's and 3 Y's, right? 3X plus 3Y must total how much? What must all those together total? 180, because they make one side of a straight line, huh? One side of a straight line makes 180, so 3x plus 3y is 180. But that's all we have. We don't have a second equation. See how on parts A and B, they always gave us a second equation? If you have 2 letters, you need 2 equations. So why can't they? The exact values of x and y cannot be determined because the figure only gives enough information to find the sum, huh? The adding up of x and y, right? To find x and y, more information about the relationship between x and y, or a value such as, I don't know, what value would be helpful? DOA? What's DOA? I can't tell. Let me go back to the diagram. DOA. No, that's not helpful. What's DOA is the 180. That's the whole thing. That one, that's not it. Not that one. It must be the other one. EOD. I'll just write it in. It's got to be. It's the only other option. But I'll double check. What is EOD? EOD. So EOD. Yeah. If we had that, then we'd have the 3 Y's, huh? And we'd be able to figure everything out. Yeah. So there we go. Is that good? Here, it wants the measure of angle BOC. Let's go back to BOC and take a look. So, erase all this again. So BOC, where's that? BOC. Yeah, BOC. What's BOC going to be? This and this. So angle BOC is x plus y, isn't it? It's just a single x and a single y. Does that make sense? It's just this x and this y. That's BOC. Okay, well, we just know 3x plus 3y. How are we going to get, like, x plus y? What could we do to take 3x plus 3y and turn it into just 1x plus 1y? Divide by 3, huh? Yeah, exactly. So yeah, so we do have to do a step here. I didn't realize. Divide through by 3, huh? Cancel, so that'll just be x plus y, and that's what, 60? So x plus y must be 60. BOC must be 60. So we can figure out BOC. We still can't find x alone or y alone, but we can find x plus y. Does that make sense there? Thank you for that. I was going to skip right over that. So it must be 60. All right, so how about number 2? In the figure below, O is the center. Find each of the measurements. Okay, so they want each. So O is the center of the circle, and they want ACO. So AC. Oh, whoop, that's B. Going the wrong way here. ACO. So they want this, huh? That's ACO. So how am I going to find ACO? How am I going to find this angle right here? Yeah, because that angle and the 61 make 90, don't they? See how they're together? They're a right angle. So we just say, okay, this is going to be 90 minus 61. What's that? 29 degrees on that. Is that good there? And next, measure of AC. Now, this says arc. See that little mark there? That's an arc over AC. So that means this arc right here. And that means the angle. So whenever they want the measure of an arc, they want the measure of the angle from the center leading to that arc. In other words, they want this angle. from the center of the circle, which leads to that arc. I don't know if you remember, it's been a while. It's been like 5 weeks since we did this section. So it's the measure of that angle at the center, which leads to that arc. So what is that angle? How can we find that angle at O, which leads to the arc AC? How do we find this angle? Can't we subtract from 180? Because this is a straight line down there, right? Is that good? So, right, because it doesn't totally look like it, does it? Maybe.
Would it be half of 180?
Yeah. How about this? Didn't we just find that this? I just want to be careful. I think we can, but we just found that one's 29, huh? That was the last part. That one's 29, and so then that little triangle, yeah, we can just subtract from 180, can't we? Yeah, same thing. It would come out same either way. Yeah. So that would be 180. Was that 122? Thank you. Yeah. Either way. Yeah, these two do have to make. That was right. Those two have to make 180, or you could do the triangle 180. Either way, it's going to come out exactly the same. We were right on both accounts. That makes sense there. How we figured that out. So that would be 122, and then measure of angle CB. Arc. They want arc CB, so that's from here to here. So which central angle opens up to that one? Here's the center, which leads to that arc. So that's the 58. Is that making sense there? So whenever they give us an arc, they want the central angle which leads to that arc. So that'd be the 58. How about measure of arc AB? Yeah, it's the 180. Do you see it? AB goes from here all the way to there, doesn't it? Which is this central angle, which is 180. We good there? So whenever they give us an arc, it's the central angle. And finally, they say the measure of CBA. So what is CBA? This last one. So that's from C to B to A. Yeah, it's going to be all of this angle. Yeah, so it's 180 plus 58. Yeah, exactly, huh? Everybody see that? It's all of this, which is the 180 and the 58 put together, isn't it? Whatever that is. Is that 238? Yeah, 238. And there we go. Is that okay with those arcs? All right. I'll move on. Remember symmetry? Rotation symmetry. So identify the figures. Which of the following? So on question A, which figure below has one line of symmetry but no rotational symmetry? What do y'all think? Which one of those, A, B, C, or D, has one line of symmetry? B? Is it B? Yeah, B has, here's his symmetry. So line, remember, symmetry line is a fold line, right? It could fold. It's the same on both sides of that line. You could fold it on that line. It would come unto itself, right? And does it have no rotational symmetry? Yeah, that's true. It doesn't. In other words, remember what rotational symmetry is? Like, how about this one? This one, if you flipped it halfway, if you flipped it 180, it would look the same. So symmetry is same. So the word sim means same. So like that one on the end does have an angle. You could flip it, right? 180. And by the way, we mean less than 360. Of course, anything, if you turn it all the way around, it'll be back unto itself. That's obvious, right? So we're not counting 360. We're saying, does it have an angle less than 360? This has no angle less than 360, right? You'd have to turn it all the way around, and that doesn't count. So yeah, so whereas this one has 180, So he doesn't count. This one also has 180. This one has 180 if you flipped him around. So B is the correct answer. That's the one that has one line of symmetry, but no rotational symmetry. Is that good? Good job. How about part B? Which figure below has rotational symmetry, but no line symmetry? Rotational symmetry. All right, what about part B? What do we think on part B? No rotational symmetry, but or have rotational symmetry, but no line symmetry? Any answers? A, is it A? A here? See, rotation, yeah, because you can flip it 180, huh? You could flip it halfway around again. It would look totally the same if you turned it halfway around. And it has no line symmetry. Yeah, there's no line you could fold that on. You might think, well, can't you just do it like right through there? But this part would go down there, and this part would go up there, and it wouldn't look the same, huh? Yeah, so yeah, good job. It's part A, because it has a 180 rotation, but it has no line. Whereas the other ones all have lines. Like that one has a couple of lines of symmetry that you could fold it on and it would be onto. This one has a couple of lines. That one has a line. All the rest have lines of symmetry, don't they? Good. And then how about part C? Which figure has one line and it does have rotational? One line and rotational. Which figure below has one? Oh, that's not working. That's not possible, is it? Do you see that? This one, first off, has a bunch of lines, right? You could fold it about any of those lines, or even more. This line, or that line. That one has a ton of lines of symmetry. You could fold it about. It doesn't just have one line. This one has one line, but it doesn't have rotational, right? If you flipped it halfway around, it would look different. You'd have to go all the way around, and we don't count that because anything will do that. And how about the anchor thing here, the arrow going down? It's got one line, but no rotational, huh? And how about this one? This one has a 180-degree rotation. If you turned it halfway around, it would look the same. But it doesn't have any lines, does it? No lines. So this is not possible on that one. So they want us to complete the drawing so M is a symmetry line. I think these are probably not too bad for you. So down here, which of these three drawings makes M a line of symmetry? Yeah, that one's pretty easy, huh? And on part B, which of these, taking this figure here and bringing it down to which of these makes it a line of symmetry? Yeah, you'd like a lot of those on the exam, right? Maybe 10 or 11 of those. Yeah, all right. All right. Oh, yeah, remember this terrible one? Oh, now I'm not going to, like I said, when I say it's on the, I'm not going to give you like this whopping thing with parts A through K and math from. It's not going to be that intense. What I mean, but I will give you like one little question from this. I might say, I might grab one of these. I don't even remember. It's been so long since I made the exam, and I have several versions. I might grab that and say, is it equilateral or is it parallel? I might ask you one or two questions. I'm not going to ask you 27 questions like this. So that's what I mean. So master the practice exam, and you're totally good for the exam because it's a smaller version of the same thing, not nearly as long. This is super long. All right. So, so I'll probably ask you one, maybe two little questions, specific questions from this kind of thing. All right, so let's do what we can. I don't remember the whole thing either, to tell you. It was really a tricky one because remember it had parts that you can't do and all that kind of stuff. All right, let's see what we can remember. So we're supposed to drag each of the shapes. And remember, more than one would go into boxes, and some boxes had none. They really made this a tricky question. I mean, it was painful, but it was really good, kind of like a really hard workout, right? It really made us get in shape with these little facts. Oh, and you get a 3x5 card. I don't want to forget to say that, right? You all know that, right? 3x5 card. Write anything you want on both sides. Put in typed stuff or written stuff or diagrams or whole problems, whatever you want. And students often ask me a good question. Well, how do we know which one? basically as you do the practice exam, that's probably the best way. As you're going over part 1 and part 2 of the practice exam, anything you need, because the real exam will just be a subset of the practice exam. I promise there won't be anything on the real exam that wasn't on the practice exam. So if you learn these and put whatever you need, so that's going to be different for every student. You know, some things you remember easily, you don't need in your card, some things you will. So like you might put some of these facts. So definitely I would put on my 3x5 card some of those facts. Remember, like, maybe I'll write a couple here. Let's go to the end here. We got a little room to write. And I'll say, okay, remember that an isosceles, how about these? An isosceles triangle, it means 2 or 3 sides that are equal. That's a tricky fact, because we always just think of 2 sides equal, and that's usually, but really it can be 3. It actually is 2 or more. It's 2 or 3. And they try to trick you with that. So on that's the exact kind of thing they're going to try to trick you on this question. It's 2 or 3. What else? I'm trying to remember something else like that. I think was it a parallel? You guys know a parallelogram. Parallelogram, you know, has like opposite sides that are parallel. Make it a little better. So like this, right? And then a trapezoid. Yeah, maybe it was a trapezoid. A trapezoid has, I think, 2 or all 4 sides parallel. Yeah, because again, he's kind of like the isosceles. He can be that or more. So now there's normally we think of a trapezoid as something like this. You know, see how the top line and the bottom line are parallel? So that's a trapezoid. Normally, it's just like the top and the bottom, or maybe the right and the left are parallel. But it's also a parallelogram. A parallelogram is a kind of trapezoid. See how the top and the bottom are parallel, but also so is the left and the right. It's really a parallelogram, but it's technically a trapezoid as well. See, that's how they're going to try to trick you, right? It's like, you know, it's like a poodle is a kind of dog. A trapezoid is a kind of, a parallelogram is a kind of trapezoid. And the same thing goes with, what was it? A rectangle, right, has 2 or more equal sides. So you could have a rectangle like this. That's the kind we're normally used to thinking of. But also a square is a perfect rectangle, in other words. It's a perfect rectangle because all 4 sides are equal. So a square is a perfect rectangle, like a parallelogram is a perfect trapezoid. Does that make sense? So they try to fool you with those kind of definitions. Let's go back. I'll probably think about more as we go. That'll be on the YouTube if that was too quick, if I flashed off that. So let's go back. Let's go one by one. So let's take this thing here. So this thing here is it's got 2 equal sides, it says. Right? So they're marked 2 equal sides. So let's go through it. Is it an isosceles triangle? Yeah, for sure. For sure. So I'll say A. This is A. It's an isosceles. But there's more than one category sometimes. Is it isosceles but not equilateral? Yeah, it's that too. Right? It's isosceles, 2 or more, but it's not equilateral. It doesn't have all 3. Yeah. So it fits in categories A and B. And then is it equilateral but not isosceles? That's an impossible category. Let's cross that category out right now. Do you see that? If you're equilateral, you have all 3 sides equal. Well, then you are isosceles automatically. Remember? See, they're trying to trick us. Let's go back. Here it is. Remember, isosceles means 2 or 3 sides. Equilateral is a perfect isosceles. So right? So they're trying to trick us again. That's like saying it's a square, but it's not a rectangle. Well, if it is a square, it's a perfect rectangle. If it is equilateral, it's a perfect isosceles. See that? See how they're trying to trick us? So here's equilateral. That's a perfect isosceles, like a square is a perfect rectangle, or a parallelogram is a perfect trapezoid. Because all those definitions are like 2 or more. aren't they? They're not just two. I know we kind of think that way, like, isosceles is two sides, but it's really two or more. So equilateral is in there. All right, so watch out. So they have some fake you out categories. Don't let them get you. So that's never going to be, is it? Nothing's going to go in that category. How about the next one? Parallelogram, but not a trapezoid. Another fake, right? If it's a parallelogram, remember that's a perfect trapezoid. So that's a fake category. Trapezoid. Oh, no, wait, no, I'm getting confused. No, I'm right. These are hard for me too. A trapezoid, but not a parallelogram. Can you be that? Yeah, you can be that, right? You can be a trapezoid, but you're not a parallelogram. You just have two sides parallel, not all four. Yeah, that can be. I just want to cross out the fake ones right now. How about here, a rectangle, but not a square? Can you be a rectangle, but not a square? Yeah, you're just, you're like that, but you're a rectangle, but you're not a square. Can you be a square but not a rectangle? No, that's another fake category, right? Because if we're a square, then we're a perfect rectangle, huh? And then a square but not a trapezoid. Can you be a square but not be a trapezoid? No. If you're a square, right? If you're a square, you're a perfect trapezoid. Remember what trapezoid means? At least two sides are parallel? Well, yeah, everything's parallel in a square. I mean, top, bottom, and right, left is what I mean. Right? If you're a square, you're like everything. Right? If you're a square, you're a perfect trapezoid. You're a perfect parallelogram. You're a perfect rectangle. Right? That's the perfect little shape, that little square. It fits all the categories. Does that make sense? So that's another one they're trying to fool us on. If you're a square, you are a trapezoid, right? Is that okay? Want me to go back here real quick? So remember the trapezoid definition? A trapezoid has two or four sides parallel. Top and bottom, or right and left, or both. So yeah, square fits that, doesn't it? So have these on your 3x5 card and understand them. Like I said, I'm just going to give you like one or two, probably two little logical questions like that. I'll say, is a trapezoid a square? Or is a square? I'll say something like that. Or give you a picture and say, is this a trapezoid? As long as you have those logic down, it'll be way easier than this crazy thing. And then, how about the bottom down there? A rhombus, but not a kite. A rhombus and a kite. That's all the room I could fit on the copy thing there. So it's a rhomb. Now, what's up with rhombus and kite? Do you remember those? Let's go back. Those are probably some of the least familiar, weirdest ones. I'll go to a new screen here. So rhombus. We made a bunch of rhombuses in our constructions, remember? What's a rhombus? Remember, it's like a diamond. And it has all four sides equal. Four equal sides. Let's just leave it at that. Four equal sides. So four equal sides like a diamond. And notice it is, opposite sides are parallel. Remember we learned all that stuff about that's why we kept making diamonds for our constructions, because when you make a diamond, the opposite sides are parallel. Remember all that? The opposite sides are parallel, which means it is a parallelogram automatically, isn't it? Remember that? And then we had a kite. Now, what was a kite? A kite was kind of like a diamond where two of the sides were longer and two of the sides were shorter. Kind of like that. These two were the same and those two were the same. Remember that kind of thing? So that was a kite. A kite. So a kite, two sides equal and other two sides equal. Right? So a kite has two sides equal and other two sides equal. But do you realize a perfect kite would be a rhombus? Do you see that? There could be a rhombus. It could be that all four are the same. In other words, it could be like this, where they're actually all the same. A rhombus is a perfect kite, isn't it? So again, don't let them trick you with that. Like a square is a perfect rectangle. A rhombus is a perfect kite. It's a perfect little kite. So have all those on your 3x5 card to whatever degree you need them, to whatever words are most helpful for you on that. Does that make sense on that? So can we go back and let's look at their tricky questions again. Like I said, this question's like a really hard workout. It really makes us think carefully. So right now, how about this one down here? Can you be a rhombus but not a kite? No. That's what we just saw. A rhombus is a perfect kite, isn't it? Right? Remember that definition we just saw? No, that's another. They're doing another fake out. Right? No way. If you're a rhombus, you have all four sides the same. Of course you're a kite. Kite just has top two, bottom two, huh? So if they're all four the same, yeah, that's a perfect kite. So if you're a rhombus, you can't be a rhombus but not a kite. How about J? That's just rhombus straight and K is just kite straight. Okay, so there we go. So we crossed out, what is it, 1, 2, 3, 4, 5 of those categories were bogus categories, weren't they? They were trying to fool us. Nothing is going to go in those categories. Let's get back to the problem. So the first one is A and B. What about this one? What kind of shape is that? Yeah, see how it's got this and then double, double. So that's a kite, isn't it? That's K for kite. Right, good. It's convenient. K goes with kite. All right, how about the next one? The next one has got single, single, double, double. What's that? That's another kite, isn't it? Am I missing something? Just another kite. K for kite. Right? How about the next one? Rectangle. And so in other words, this rectangle, it's got double here and single. So it's just a rectangle. So now careful, they can try to fool us with the categories. What is it going to be? Which categories would it fit in? Oh, rectangle but not a square. Yeah, it's F. So it's F, rectangle but not a square down there. And that's it, huh? Yeah. Let me know if I miss. Oh, wait. Oh, no. Yeah, I was thinking it was going to be a rhombus, but it's not a rhombus. It doesn't have all four sides equal. No. How about this next one here? This is a... Is there a double mark there? Or a, no, those are all single marks, aren't they? So those are all... So all four sides are the same, and opposite sides are parallel. So what is that shape? That's a rhombus. First and foremost, that's a rhombus, J. That's a rhombus. But what else is it also? See how it's also a kite? Remember, a rhombus is a perfect kite, right? A kite has two sides. Well, that's got all four sides. And what else is it? It's a parallelogram. Oh, but they don't have parallelogram category. If they did, it would be a parallelogram too. They don't have like just a parallelogram category. So that one is a rhombus and a kite, because every rhombus is a kite. Huh? Does that make sense? Let's finish up this one at least here. Coming on down to this next shape. What is this one? Down here. So, what do you think? Trapezoid, but not a parallelogram, huh? See how the top and the bottom are parallel lines, but the right and left are not? So it's a trapezoid, top and bottom are the same, right and left are parallel, right and left are not. Trapezoid, but not a parallelogram. Good. How about the next one? This one right here. Let me see the marks here. It looks like single mark, and that's it. Well, it's not quite a kite because those other two aren't equal, right? It's got to be top two and bottom two to be a kite. Is that just nothing? Unless I'm missing something. I think that doesn't fit anything. This is nothing. It fits in. See, they're being tricky on this question. It fits in none of those categories because it's not quite a kite. If those bottom two are equal, it'd be a kite. All right? How about this next one right here? That's an equilateral triangle, but what categories would it fit in? Because they didn't just make equilateral. A for isosceles, because it is isosceles. Isosceles means two or more. Two or more sides that are equal. So that's certainly isosceles, and that's it. We can't put it in B. It's not isosceles, but not equilateral. All right. How about this one right here? Double, double, single, single. What's that one? That's a parallelogram, but we don't have parallelogram here. Does that fit in none of the categories? Yeah, that's a nothing again. Unless I'm missing something, and I might be. But I don't think so, because that's just a parallelogram, and they don't have parallelogram category. It's not a rhombus, not a kite. Last one, the square. What is that one? That one's like everything. I mean, not a triangle, but it's a rhombus, right? Because all four sides are equal. It's a kite, because kite is two equal. It's got all four equal. It's yeah, that's it, I guess, huh? I was expecting so much more, but that's it. All right.